Okay, today we are going to take some basic notes on scientific notation, and it should help anybody who needs to either write numbers in scientific notation or convert numbers from scientific back to standard notation. Okay, so we will start with writing numbers in scientific notation. First of all, you have to understand that scientific notation is a way to, and we'll write this little note here, we want to be able to write very large or very small numbers. And so that's what scientific notation actually is. It's a way to write very large or very small numbers, and usually it cuts down the amount of digits that we have to write down. It's a mathematic way of shortening what you're writing. Okay, now there's a format that goes with this, and the format is always going to be this. Your first number that you write down has to be greater than 1, but less than 10. And then you're always going to do times 10. So that's going to be a base number that we multiply by every single time. And then there's going to be an exponent on that 10. And the exponent is going to depend on how many spaces we're moving the decimal point in a minute, which I'll show you. Okay, so let's say you have example 1, 514,223, and you're asked to write it in scientific notation. First, you have to note that there is a decimal and every number, and if it doesn't appear, it's at the end, so we're going to put that in. And to write in scientific notation, that first number really has to be between 1 and 10, so we're going to move that decimal to get that between 1 and 10. And the place we're going to move it is right after the first number, right after the 5. So when I go to write this in scientific notation, my first number will be 5.14223. Same number, only I've moved the decimal so that it is right after the 5. And now we're going to write times 10. Because we're timesing by a base of 10 in scientific notation every time. And the exponent that's going to go on that 10 is going to be the number of spaces we move the decimal. So it started here, we moved it 1, 2, 3, don't count the comma, 4, 5 spaces. So our exponent's going to be 5. And this is the answer. This is what we want in scientific notation. Okay, in case you didn't get it, let's try this again. So this is not quite as big of a number, 6,120. Again, there is a decimal on it. It's at the end. So we put that in first. Now, in order to get our first number between 1 and 10, we got to move that decimal so that it is just behind the 6. There should only be one number, then a decimal. So our first number is 6.12. Technically, we can put the 0 on, but from here on out, if all that's left is zeros, we can leave those off. And you'll see why here in a few minutes. Times 10. Always times 10. And how many spaces did we move the decimal? 1, 2, 3 spaces, so our exponent will be 3. And that's our answer. Now notice on these, our exponent was positive. The reason the exponent was positive is because we were working with very large numbers, okay? So when we're working with large numbers, our exponent will be positive. Now when we get down to the next section, we're working with very small numbers. So you know it's very small. It starts with a 0 point, and then our numbers are behind the 0. They're to the right of the 0. That means this is a really small number. These are numbers that we see like under a microscope. And so to do this in scientific notation, you really use kind of the same method. This time, though, the decimal's already there, So we're going to find where we're going to move our decimal. So the first number that we see that's not a 0 is an 8. So we want to move the decimal so it's behind the 8. So our first number is really going to be 8.3. And then we're going to still write times 10. And our exponent, again, we're going to count. The decimal started here, so we moved it 1, 2, 3, 4, 5, 6 spaces this time. But since this is a really small number, our exponent is going to be -6. And this is our scientific notation for that. Okay, try it again. Okay, on the U try, we've got this. We've got a decimal that's already there. We need to move it so that it is behind the first number that's not a 0, so behind this 6. And so we have 6.58219 times 10 again, and count the number of spaces. It started here, so it only moved 1, 2, 3 spaces this time, and it's a small number, so we use a -3. And so that's how you do the really small numbers. So notice that these really small numbers, they have negative exponents. All right, and it's not negative numbers, it's negative exponents. They make really small numbers. Okay, so on the work that we have, extra examples today, on side 1, practice 1, side 1, I'll do an example, 2 examples with you, and then I'll make a different video for writing numbers in standard. Okay, so scientific notation here, the first one on the worksheet that we've got is 18,451,000. To write this in scientific notation, you have to know, oh, there's a decimal, it's at the end. Where do we want to move the decimal to get it in scientific notation? We want to move it between the 1 and the 8. So our first number is 1.8451. We can stop writing once all that's left is zeros. That way, that's the whole point of scientific notation, is to shorten it if we can. Times 10, and now our exponent is going to be the number of spaces. 1, 2, 3, don't count the comma, 4, 5, 6, 7 spaces, so our exponent is 7, and it's positive because it was a very large number. Okay, one more try here. Number 2, we're starting with a very small number, so we know already our exponent should be negative. We have the decimal right here. We want to move it right after the 4. Okay, so our first number is 4.826. That number is between 1 and 10 now. That's what we wanted. Times 10, and we count the spaces. 1, 2, 3, 4, 5, 6 spaces this time, and it's a very small number, so it is a -6. Okay, so that should be helpful in how we write numbers from standard notation into scientific. If you want to know the other side and how to convert back from scientific to standard, you'll have to check out the next video.